For my project, I designed and taught a section of a college sophomore-level computer science course. There's a lot that goes into designing a college-level course, so this video highlights only a small fraction of what I created. First, I made the textbook optional and I wrote my own reading assignments to replace it. This makes the course more affordable for students, makes the text more approachable, and makes students more accountable for the reading. The reading assignments are stored as quizzes in Canvas. Each is designed to include small blocks of informational text separated by exercise questions to help students apply what they learn as they read. Students see their score as soon as they submit, and they can attempt the assignment multiple times to improve their understanding. I created 25 of these micro-reading assignments for the 15-week semester. I also changed how class time was used by designing additional live coding exercises. Live coding provides a model of expert performance, and it has been shown that students learn more from live coding than from reviewing static code. In the recursion unit, for example, I spent a few class periods coding a solution to find all dictionary words on a Boggle game board, such as the one shown here. The students brought laptops to follow along as I wrote and talked through my code. The Boggle example uses two recursive functions. The first one is a binary search function that is used to find out if a string found on the board is a valid dictionary prefix. The second is a recursive backtracking function that's used to search through all possible paths of the game board. This Boggle exercise provided the students with some insight into how they should approach Lab 4, which required them to write a recursive backtracking function to find a path through a three-dimensional maze. I made only small changes to most of the labs, but I rewrote Lab 9 so that it could be graded by an autograder. For Lab 9, students create their own map implementation using a hash table. Students write their own hash functions to see how difficult it can be to write a hash function that distributes values uniformly. To test their maps, students are provided with a word counter class that breaks a text file apart by words and then uses the student's map to count the occurrences of each word, producing a file that sorts these words first by most frequent and then alphabetically. Here's some example output for Harry Potter and the Sorcerer's Stone, for example. These few examples give you just a small taste of my experience in designing and teaching this computer science course.